All right, let's continue what we were doing yesterday. Composition of functions. It's not too bad. If you have a good idea, it's pretty fun. Like this question 3 is kind of interesting. It says use the graph to evaluate each expression. It's going to be a 2-second answer. So for the first one, it says f of g of 2. You can rewrite that as fog of 2 if you want it like that. These two, they mean the same thing. It's not actually an O, I just like to call it an O, but it's like f of g of 2. So let's look at the first one, f of g of 2. So again, you have to start from the inside out. F on the outside stays where it is. Look at this graph. What is g of 2? What's the y value when the x value is 2 for g, which is like the blue curve there?
It's 1.
So
No, wait, it's 5.
it's 5. And now we have f of 5. What's f of 5? So boom, boom, up here. That is also a 5. X value is 5 for f. The y value is also 5. So that's the answer for the first one. These are pretty simple. Look at the next one. G of f of 4. F of 4 is a 3. So you get g of 3. What's g of 3?
It's 5.
It's 5. Then you're done. Or is it actually g of 3? It is. I'm looking at the wrong one. It is 5. The next one is GOG of -2, which is the same thing as g of -2. So g of -2 is a positive 1, right? So this thing is positive 1. And then we still have the g on the outside. What's g of 1?
4.
Yes, and you are done. The last one, FOF of 2, which is the same thing as f of 2. F of 2 is what?
-1.
-1. So then you have f of -1. What is f of -1?
It's not there.
It's not there, right? So this one you can say it doesn't exist. Or it says it's not in domain, you can say that. The next one, we have a little word problem. I mean, it's gonna be linear, judging by the equation. So d is the distance, t is time in hours. So this represents the distance traveled, which is going to be 80 times t, where t is hours. And then we have another equation, which is the cost. So this is a dollar amount, and the cost is now dependent on the distance driven. Part A says determine C of D of 5 and interpret your result. So again, it's not very difficult. It's just C of D of 5. C on the outside stays as it is. What is D of 5? So you gotta look at this equation. D of 5 would be 80 times 5, right?
Mm-hmm.
Which is 400. And now we go to C of 400, which is this equation. That'll be 0.09 times 400. 0.09 times 100 is 9. 9 times 4 is 36. So the answer to this is 36. And that's it for part A. It says interpret your result. What this means is if you've driven for 5 hours, right? You gotta first look into the inside. If you've driven for 5 hours, then it's gonna cost you $36. That's the interpretation for part A, which is quite steep. What is this? Is this a rental car or what? Maybe not. I mean, it's not too bad. Depends on the gas prices, but 5 hours, $36. Part B says, describe the relationship represented by C of D of T. So what does that represent? Which is like, you can call that cot of T or C of D of T. It basically gives you the cost depending on the hours. So this one gives you the cost in dollars given if they've given you the number of hours you're driving. So that's the relationship. If you have the hours, you can get the cost by doing C of D of T. And that's it. Pretty simple stuff, nothing too complicated. Could possibly get a little bit more trickier here. It always does. But most of these are polynomials. So how hard could it possibly be? Let's go one by one. It says find f of g of x, and it also says find g of f of x. So you got to do both ways, and we got to find the domain. All right. The first one, f of g of x. So f stays on the outside. G of x is x minus 1. Look at A. What's f of x minus 1? If f of x is 3x squared, what's f of x minus 1?
You just add a -1.
You add a minus 1. So again, you're going to replace the x with whatever you have in this bracket. So in this case, you're going to replace that x with 3 times x minus 1 squared. Okay? 3 times x minus 1 squared. It's a polynomial. What's the domain? Polynomial means x, x squared, x cubed. They all have the same domains. Can be anything. Has no restrictions. Graphically, this would look something like this. Your x squared looks like this. This is the parent function. This 3 makes it a little bit narrower. That's a vertical stretch. It's basically like pinching these two ends. That's what the 3 does, or that's what the a value does. You pinch both of these, and then you pull it up, which will give you the blue curve. The minus 1, does it move to the left or to the right? It's inside the function.
To the right.
To the right, exactly. So the final graph would look something like this. Boom. So not too difficult. The x-intercept here would be a 1. So that's f of g of x. We can also go the other way around. We can do g of f of x. G stays on the outside. F of x is 3x squared. So if g of x is x minus 1, what's g of 3x squared? Again, you're just going to replace the x with what's in this bracket. So replace x with 3x squared, and then the minus 1 is still on the minus 1 on the side. The -1, does it move it left, right, up, or down?
Down.
Yes, because it's on the outside. Last time we had 3 x squared -1, something like this.
Mm-hmm.
This would move it. It's something like this. I don't remember exactly what it was. This is gonna move it to the right, but this one's gonna move it down, and it's also a polynomial, so it's gonna look something like this. The domain will be XER. That's it for that one. Not too bad. Let's do one with higher power, maybe this one. D. We're first gonna find f of g of x. We know g of x is x plus 1. So for this expression, what's f of x plus 1? Again, you just want to replace it. Like, look at this. I'll show you like 10 of these right now. Let's say there's a +5. There's no +5 here, but let's say there's a +5. F of x plus 1, you're going to replace every single x with what you have in this bracket. So this will be x plus 1 to the power of 4 minus x plus 1 squared. But the 5 doesn't have an x, it just kind of hangs at the end like this. If you have let's make this more complicated. If you have f of x4 minus x2 plus 5 for the same expression, you want to replace the x's with what you have in this bracket. So look at this. It's going to become x4 minus x2 plus 5 to the power of 4 for the first term. We replace this x with what we have in this bracket, and then the fourth power is on the outside. Minus, the next one would be x4 minus x squared plus 5 squared. And then the plus 5 doesn't have an x, so it's just going to hang on the outside like this.
Mm-hmm.
Replace the x's with whatever's in this bracket, and this bracket can change. These are the inputs. The inputs are always going to change, but you just replace that x with what you have in the input. So using this idea, if f of x is x4 minus x2, what is f of x plus 1?
It's x4 minus x squared plus 1.
No, it's going to look like this. So again, there's an x there, right? So x4 minus x squared. There's an x here, there's an x here. You want to replace both of these x's with this bracket.
So x plus 1 4 minus x plus 1 squared.
And there you go. That's going to be the final expression. This is a quartic opening up. Graphing this is not easy because you have to be in the factored form to graph it. 1 4 minus 1 squared. It's going to go through the origin. We know that much. It's going to open up and it's going to go through the origin. Could look something like this. It's a polynomial function. Again, x power 4 is polynomial, power 5, power 6, power 100. The domain, there is no restrictions. It's going to be XER. Now let's flip it the other way around. So that was f of g of x. Let's try g of f of x. So g stays on the outside. F of x is x4 minus x squared. If g of x is x plus 1, what is g of x4 minus x squared? we'll replace the x's, right? There's only one x here on the output or in the main function. Replace that with what you have in this bracket. So it'll look like, again, that x, look at this, that x is going to change into x4 minus x squared. This used to be x, and then the plus one doesn't have an x, so it's going to stay on the outside like that, which is also a polynomial function, and the domain will be XCR. Cool?
Mm-hmm.
Do you understand this? Replacing the x's?
Uh-huh.
Just replace the x's with what your input is, or what you have in the bracket. Let's try the next one. F is sine x, g is 4x. F of g of x. So this will be f of 4x. If f of x is sine x, what's f of 4x? There's only one x here. You want to replace this x with what you have in this bracket. So it'll be sine of 4x. Yeah?
Mm-hmm.
What about the other way around? G of f of x. We know f of x is sine x. If g is 4x, what's g of sine x? You're going to replace this x with what you have in this bracket. So it'll be 4 times sine x, okay? So what's the difference between these two? The domain for both of them is XCR. Sine, cosine, polynomials, exponential, absolute value, all of those have a domain of XCR. So how do these two differentiate? If it's on the inside, like this, sine function has a period, the parent function has a period of 360 degrees. Looks like this, has a maximum at 1, has a minimum at -1, and then goes through intervals of 90 degrees. So it starts at 0, 0, and at 360, because it's a circle, comes right back to 0. Now the 4, what this does is it's a horizontal compression. It shrinks it because it's inside the function. It's going to shrink it this way. So if your period was 360 before, this 4 will shrink it by 4 folds. So the new period is going to be the original period divided by the k value. So the new period is going to be 90 degrees. So how is that going to look? A sine function does things in 4 increments. Like if you look at this, goes up, down, down, up. So we're going to do the same thing within 90 degrees. So what's a quarter of 19? Sorry, 90. That is not divisible. What is that? 22.5, I think. Yeah. So the graph of sine of 4x would look something like this. Now it's going to be every 22.5 degrees. It's going to start where it started before. It's going to go up to a maximum of 1 at 22.5. Then at 45, it would be 0. At 67.5 comes down to -1. And at 90 goes back to 0. So if you compare these two graphs, this has shrunk by 4 folds. If you were to draw it on the same graph, it'll look something like this: 22.5, 45, 67.5, and at 90 it'll come back down. So that's shrunk by 4 folds. That is sine of 4x. if this number is inside the function, it's going to affect it horizontally. It's going to move it left, right, or it's going to shrink it left or right. The 4, because it's being multiplied, it's going to shrink it. Now, if you compare this with this 4, is this on the outside or on the inside?
The outside.
Is that going to affect the x or the y? If it's on the outside. Inside is x, outside is y. So that's gonna move it up, not move it. It's gonna stretch it up in this direction, up and down. If it's on the inside, it's gonna shrink it left and right. If it's on the outside, it's gonna do it up and down. It's gonna stretch it. So this is a stretch. Originally, our max and mins were 1. Now our max and mins are gonna be multiplied by 4 folds. Like this. Everything else will stay the same. The period is still 360. It's still gonna start at the origin. It's just gonna look a lot more lankier like this. At 90, it's gonna be maximum at 4, 180, 0, 270, -4, and 360 back to 0. So that's the difference between these two. The 4 on the outside stretches it up and down. The 4 on the inside shrinks it left and right, okay?
Mm-hmm.
This is called the k value. If it's inside the function, it's k. So k would be 4 here for this guy. But this 4 is outside. That's going to be your a value. A will be 4. That a stands for amplitude. Amplitude is the distance from the center line to the maximum or the minimum of a curve. We have one last one here, f. Shouldn't be too difficult. Let's see. F of g of x. G of x is x plus 5. So you do f of x plus 5. If f of x is the absolute value of x minus 2, what is f of x plus 5? You just want to replace this x with what you have in this bracket.
So the absolute value of x plus 5 minus 2.
Yeah. So you get x plus 5 minus 2. Now for the other one, g of f of x, g of absolute value of x minus 2. So what's g of absolute value of x minus 2? If g of x is x plus 2, what is g of absolute value of x minus 2? Just replace this x with what you have in the bracket.
The absolute value of x minus 2 plus 2.
Plus 2, the 2's cancel out, so it's just the absolute value of x. Absolute value of x, very similar to quadratic, except it's pointy. Quadratic is curved. It looks like a V. It's made up of two linear lines, the absolute value of x. The plus 5 doesn't move it left, right, up, or down. It's inside the function.
It moves it left.
Yes. The minus 2, left, right, up, or down?
Down.
Down. So initially this started at 0, 0. This function, there's no stretches or anything going on. It's going to move it left 5 and down 2. So now it's going to start at -5 and -2. It looked the same, but it's just going to start at a different position like that. And there you go, that's a sketch. And the domain for this one, like everything else here, is also XER. These next ones are going to be a little bit trickier. because now we're not dealing with polynomials. So let's look at the first one. F of g of x. You have f of the square root of x minus 4. What's f of square root of x minus 4? If f of x is 3x. You just want to replace this x, right? Look at this with that. So you get 3 of x minus 4, okay? What about the other way around? G of f of x. This is the same thing as g of 3x. If g of x is x minus 4, what's g of 3x?
The square root of 3x minus 4.
Yeah. No, they're not the same functions because for one of them, 3 is on the outside, the other one, 3 is on the inside. For this guy, the stretches don't really affect the starting positions. It is gonna make it a little bit, it is gonna pinch it up, but it doesn't affect the starting position. The a and the k value, they do not affect the starting position. A means if it's on the outside or on the inside. So the minus 4, does it move it left or right? It's on the inside.
Right.
Yeah. So your graph would look something like this. This is for f of g of x. What does the domain look like for this? Starts at 4 and is going to the right. So what is its domain?
X has to be greater than 4.
Yeah, can be exactly 4 as well. What does the range look like?
It's above 0.
Yes. So y has to be greater than or equal to 0. So that's for 3 of x minus 4. For this one, what you have to do with this one is that the k value should always be, it's multiplied with the x, but it should always be in a bracket. What I mean is, right now this is not in the right form. It needs to be in this form, k of x minus d. If there's a d value, we have a d value here. The 3 should be outside the bracket. So look at this. The function is still square root. 3 is now outside. Bracket open, x minus. If I'm pulling out a 3 from a 4, I'm left with 4/3, like that. So this is the right form. If there's a k value that's being multiplied with the x, there's also a d value, you have to write it like this. Why? Well, because your starting position is not at 4 units to the right. It's actually at 4/3 units to the right, which is 1.333, like 1 and 3 recurring. So the sketch of this would look something like this. Okay?
Mm-hmm.
The range is the same, but now the domain is it has to be bigger than 4/3, bigger than or equal to 4/3 for the domain. Let's try doing, I don't know, 3 of these, I guess, where we're going to combine something other than polynomials. Let's look at D. Let's first do f of g of x. G of x is the square root of x minus 1. If f of x is 2 power x, what's f of x minus 1?
X minus 1. Wait, no.
replace this x with what you have in the bracket.
2 to the power of x minus 1.
Yeah. Now, for an exponential function by itself, it doesn't have any restrictions. 2 power x is XCR, the domain. But now this function will have restrictions. It's because of the root. What's the domain of this? Can x be 1?
No.
Yes, it can, because then you'd get 2 to the power of 1 minus 1, which is 2 to the power square root of 0, which is 2 to the power of 0, which is a 1. So x can be exactly 1. What about 0? Can x be 0? Gotta look what's gonna make the square root a negative, because you can't have the square root of a negative number. Can x be 0?
It can't.
It can't. So the biggest value, or the smallest value x can take is 1. If you put a number that's less than 1, then you'll get a square root of a negative number. So here for this, the domain is going to be x is bigger than and equal to 1, okay? Like that.
Mm-hmm.
For the range, what about the range? We may have to make a table of values here for this one. At 0, we just did it earlier, it's gonna give you a 1. Sorry, not at 0. When the x value is 1, it'll give you 2 power 0, which is a 1. Let's say when x value is 5, so that's square root of 4, 2 power 2 is a 4. So the graph of this looks something like this. What's the range? The possible y values. If it starts here, this is
Greater
called,
than 1.
yeah, greater than equal to 1, and you're done. Just like that. Now let's flip it. By flip it, I mean we're gonna do it the other way around. We're gonna do g of f of x. Again, we've done this many times. Look at this. It's gonna be g of 2 power x. Replace this x with what you have in this bracket, so it'll be 2 to the power of x minus 1. Now this one's complicated, I think, a little bit. It's a square root function, right?
Mm-hmm.
What's the range of a square root function? It's gonna be y greater than equal to 0. This is a square root function, yeah?
Mhm.
What about the domain? You can't have a negative number in here, yeah? So look at this. 2 power x minus 1 must be smaller than or equal to 0. So 2 power x must be less than or equal to 1. What value of x would make this equation true? It's not an equation. 0, exactly. So look at this. X has to be less than or equal to 0, okay? That's a restriction, basically. I did it the other way around. What this means is, I should have written it like this. It can't be. If x were to be less than, it can be exactly 0, that's fine. That's just going to give you 1 minus 1. But if x is less than 0, you'll get a negative number, yeah?
Mm-hmm.
So that's a restriction. X has to be greater than or equal to 0. Otherwise, you'll get a negative number inside the root. Let's look at E, log n 10 of x. Remember, these are inverses. F of f inverse of x and f inverse of f of x is just an x. So here, if we do f of g of x, so f of log of x, that's equals to 10 to the power of log of x. What is this equals to if they're inverses of each other? these two cancel each other out because they're inverses. 10 and log, 10 power x
Mhm.
and log x are inverses. So you're simply left with an x. Same thing if you do it the other way around. If you do g of f of x, then you'd get log of 10 power x. Log and 10 are the inverses. The order doesn't matter, like here. F inverse can come first, F can come first. What came first, chicken or the egg? It doesn't matter. They're gonna cancel each other out. The answer is X. And the domain and range is XER for X. It's just a straight line. Let's try F. F of G of X. Look at this. It's if you see it, you see it because it's like a very quick answer. All you have to do is replace this X with whatever you have in that bracket, like that.
Mhm.
Okay. This doesn't have any restrictions, I don't think so, because sine of X is XER, and the exponential function is also XER. Let's do the other way around. What's G of f of X?
Five to the power of 2 sine x plus 1.
Yes. And that's it. Let me just show you what these graphs look like, because it's not always easy to graph some of this. If it's a polynomial or something, then that's whatever. But if you throw in sine and exponentials, you're gonna get something called dampening, which I'll show you in a second. It's very difficult to graph by hand. So the red one is sine of the exponential function, yeah?
Mm-hmm.
What is happening to the period? You know what period means? Period means one cycle. Is it going up or down if you look at the red curve?
Now,
Yeah, it's becoming faster and faster and faster, yeah? So
mm-hmm.
this could represent, let's just quickly look at the blue one. The blue one is pretty consistent. It's because your main function is exponential. Exponential functions are pretty consistent. But for the red one, the main function, by the main I mean the one on the outside. That's the main function. The main function is sine, which is a periodic function, but the period is changing. So this could be an example. This graph could be an example of like a bridge swaying during heavy winds. You know what swaying means? Like when it moves left, right. Also happens to buildings during earthquakes and whatnot. So usually to model something difficult, you're gonna need complex functions. This next one is pretty fun, I think. It says come up with two functions. Again, you want to think of this as the inside and as the outside. For the first one, it's x squared plus 6. This is the combined function. We're trying to find f of g of x. G of x is always going to be the inner part, and f is going to be the outer part. So for A, what's f and what's g? So g is the inside part. Look at this. It's just going to be x squared plus 6.
Mm-hmm.
And f is the outside part. What's the function on the outside? Just look at this independently. What is this function? square root of x, and that's it. That's all you have to do, and you're done. Let's try for the next one, b. The inside part is the thing in the bracket. The outside part is this. So what's f and what's g for b?
F is x to the power 6.
Yeah, and what's g?
5x minus 8.
Yep, and that's it. That's easy as that. You're done. G is the inside part, yeah? G is the inside part.
Mm-hmm.
So for C, what's F and G?
G is 6x plus 7.
Yeah,
F is 2 to the power of x.
yep, and done. Easy as that. Now you got the hang of it, right? Look at this. It's very quick if you see it. D might be a little bit complicated, but again, you can treat this as the inside part, and you can treat this function as something. What do you think F and G is for D?
G is x to the power of 3 minus 7x plus 2.
What about F?
F is 1 over x.
Yeah, that's it, right? E, look at this. For E, G is the bracket 10x plus 5, and F is sine squared x. For F, G is the thing inside. What's F for F? What'll be the F?
Cube root of x.
Yeah, and you're done. This next one is a polynomial. This one's very easy to graph. Graph f, g, and f plug on the same set of axes. All right, so let's find f of g of x. Again, it's super simple. F of g of x. G of x is x squared, so you're gonna do f of x squared. What's f of x squared?
2x squared minus 1.
2x squared minus 1 is right. And now it says graph this. I'm gonna make a rough sketch, not super concerned about this. G of x looks like this. It's a quadratic. 2x minus 1 looks something like this. It's a linear function. And then finally our f of g of x. Does this minus 1 pull it left, right, up, down?
Down.
Down. This 2 is gonna pinch it, okay? Pinch these and move it up. So it's gonna look something like this. You can use a table of values if you want to be precise, but these are the sketches. Part C says, describe the graph of fog of x as a transformation of the graph of y equals gx. What this means is we are going to start here, and we are going to do something to the original parent function x squared that'll give us the red curve. So here, what did we do to x squared? There's a 2 on the outside, there's a minus 1 on the outside. BEDMAS, think about BEDMAS. Do you multiply first or do you subtract first? BEDMAS. Do you multiply first or subtract first?
You multiply.
You multiply. So the same thing is going to happen here. Before you move it down, you have to multiply it first, okay?
Mm-hmm.
So the transformations are these. You have to first account for the 2. It's outside the x squared. There's a difference between this. This 2 is inside the quadratic. This 2 is outside the quadratic. This 2 is going to affect the y values. It's going to move it vertically. It's going to stretch it vertically. So these are the transformations. 2 is outside. If it's outside, it's going to affect it vertically. And it's more than 1, so it's going to stretch it. It's going to be a vertical stretch by 2 folds. All the y values are going to get multiplied 2 folds. for the same x value. What does that mean? That means, let's say at 1, use a different color. Let's say at 1, for the parent function, your value is 1. For the 2x squared, your value will be 2. For the same x value, the y values are going to get multiplied exactly twice. At 2, if the y value here is 4, the y value here would be 8. That's what this 2 does. That's what vertical stretch by a factor of 2 means. It's going to multiply the y values twofolds. That's our first transformation. And our second transformation, the -1, it's going to move it 1 unit down. There you go. If you start up with the parent function, x squared, if you vertically stretch it by a factor of 2 and move it 1 unit down, you're going to get this combined function. Does that make sense?
Mm-hmm.
So a hall charges $9.75 to rent a reception room, plus $39.95 per person. Trying to think if that's expensive or cheap. It's not too bad, I think. Because if you have 100 people, your bill would be like $5,000, which isn't too bad. I'm assuming they're counting plates, because I don't know how else are they gonna determine how many people there are. It's not too bad. Next month, however, the hall will be offering a 20% discount of the total bill. Express this discounted cost as a function of the number of people attending. All right, so let's do this thing one at a time. Read the first sentence. $9.75 is your flat fee, and
Mm-hmm.
for every person you're paying $39.95. What's the cost equation using those two numbers?
39.95x plus 9.75.
Yeah, I'm just gonna call it n. Same thing, xn, doesn't really matter. So that's your cost. And next month, let's call it discount, will be 20%, right? If there's a 20% discount, that means you're gonna pay 80% of the price. So like this. Maybe you should call it D of C. Okay, like that. This is your first equation, this is your second equation. The question's asking you to find D of C of n. The discounted cost in terms of the number of people attending. So what'll that be here? So D of C of n is on the inside, so that's 39.95 plus 90.75. If D of C is 0.8 C, what's D of 39.95 n plus 9.75? Again, we've done this a few times. You see here? C,
Mm-hmm.
C. Now that C has changed into this. So what we do is we're going to replace the C with what we have in this bracket. So the final answer will look like this. There we go. And this expression gives you the discounted cost depending on how many people attended the whatever this is. Okay?
Mm-hmm.
It's just linear functions, 3 equations, one and done. If you're comfortable with doing this thing, this last thing that we just did, replacing what you have here with this bracket, then you're set. This next question is very similar. Okay, what's even happening here? So at time equals 0, a plane is passing over a radar station. It's at a height of 4 kilometers, and it's flying at a speed of 560 kilometers per hour. Okay, so that's going to be the horizontal distance. Let D represent the distance from the radar station to the plane, and S represent the horizontal distance traveled by the plane. All right, cool. Express D as a function of S and S as a function of T. Looks pretty difficult, but it's not too bad. Check this out. For the horizontal distance from the radar station, is that represented by S or D? You look at that sketch they've given us. Is S the horizontal distance or is D the horizontal distance?
S.
S, right? So S is the horizontal distance. And he's flying in hours. If its speed is 560 kilometers per hour, what's the horizontal distance? What's the equation for the horizontal distance per hour? After 1 hour, they're gonna be at 560. After second hour, it's gonna be twice that, so 1120, right? Third, it's gonna be 3 times as much, like that. What's the equation for this? If this is t and this is s of t. It'll just be,
560x.
yeah, 560x or t or whatever. So there you go. That's the equation for the horizontal distance. Now let's take a equation for the distance. Now this is the actual distance. This is not the horizontal. This is this distance. From this triangle, how do we get D? Gotta use, looks like it's a right angle triangle, right?
Mm-hmm.
So how do you get D? Gotta use Pythagoras. D squared, the hypotenuse, is going to be equals to what plus what? We're just looking at this triangle. The right angle is right here.
4 squared plus s squared.
Yeah, 4 squared plus s squared. We can make this like this. D of whatever, D is equals to the square root of 16 plus, and s is 560t. So there you go. That'll give us the horizontal distance. Sorry, not the horizontal distance. This will give us a total distance from the plane given time t, okay?
Mm-hmm.
This kind of answers both part A and part B. The answer to part A would just be this. The answer to part B would be the actual equation, the composition. What is going on with this one? I don't even know. It's a lot of graphs. Maybe I'll just do 1 or 2 of these. So this is f of x. Let's do at least 1 or 2 of these. Part A says fog of x. So we're doing f of x plus 3. So this is your f of x, okay? We are trying to do f of x plus 3. The plus 3, what does it do? Left, right, up, down.
Left.
Left. So look at this. Every single point on this, okay? f of x. We don't know what the equation is. This is not one function. This is probably like 3 or 4 linear functions. Every single point is gonna move 3 units to the left. So it'll look like this. Look like this. Look like, I don't know if I'm, yeah, like that. There we go. So that'll be f of x plus 3. In terms of the thingy, which one fits the bill? Do any of them fit? X plus 3 moves it to the left. Let's try another one. 2x. What about b? F of 2x. What does a 2 do? Left, right, up, down, or stretch compression?
Compression.
Compression. What that means is the x values are gonna, the y values are gonna stay the same because this affects the x values. The y values are gonna stay the same, but the x values are gonna half, okay?
Mm-hmm.
So 3 becomes like 1.5. The y values will be the same. Whatever this is, 6 becomes 3. Like that. And you can fill in the rest of the points. The rest of them are similar. We'll pick it up next time. Let's call it there.
Okay, thank you.
See ya.